Welcome back everyone to another video. We take many things for granted here on Earth. People don't take enough time to be grateful for or appreciate the wonderful science that sustains us. A prime example of this is the sun. Although something that may just be a bother on hot days, the chemistry and physical reactions that the sun undergoes on a daily basis are truly amazing. Today, if not already obvious, we will be talking about the sun. The sun is a G-type main sequence star that comprises about 99.86% of the mass of the solar system. The sun has an absolute magnitude of 4.83, estimated to be brighter than about 85% of the stars in the Milky Way, most of which are red dwarfs. The formation of the sun may have been triggered by shock waves from one or more nearby supernovae. This is suggested by a high abundance of heavy elements in the solar system, such as gold and uranium. The heavy elements could most plausibly have been produced by endothermic nuclear reactions during a supernova or by transmutation through neutron absorption within a massive second-generation star. The sun is composed primarily of the chemical elements hydrogen and helium. At this time in the sun's life, they account for 74.9% and 23.8% of the mass of the sun in the photosphere, respectively. All heavier elements, called metals in astronomy, account for less than 2% of the mass. The sun is divided into 6 different zones. First is the core. The core is the innermost 20 to 25% of the sun's radius, where the temperature and pressure are sufficient for nuclear fusion to occur. Next is the radiative zone. Convection cannot occur until much nearer the surface of the sun. Therefore, between about 20 to 25% of the radius and 70% of the radius, there is a radiative zone in which energy transfer occurs by means of radiation rather than by convection. After the radiative zone is the tachocline, the boundary region between the radiative and convective zones. The final, mostly physical part of the sun is the convection zone, where the sun is cool and diffuse enough for convection to occur, allowing an outward heat transfer. The final two are the photosphere and the atmosphere. The photosphere is the deepest part of the sun, which we can directly observe with visible light. Because the sun is a gaseous object, it does not have a clearly defined surface. Its visible parts are usually divided into a photosphere and atmosphere. The atmosphere is a gaseous halo surrounding the sun, comprising the chromosphere, solar transition region, corona, and heliosphere. Well, that does it for this video. We hope you learned something new about the sun. Next time you go outside and it is too hot, rather than complain, appreciate all the work the sun does to keep us alive. Thanks for watching, and we'll see you in the next video.